You're very used to seeing public in the heading of our classes and methods. We will be discussing more behind the meaning of this soon, but simply, this means that the classes and methods we have created can be used by other classes and methods. In order to prevent them from being shared or used, we can use private. Fields can be public or private depending on their purpose. Most are declared private, meaning they store information specific to the class and are only being used within it. So far, we have used the word static in headings, but just always assumed it needed to be there. It does not, though, which we'll learn about soon. Fields, like methods, can be static, or they can be what is called instance, but there's no keyword for instance fields. If we leave out the keyword static, Java assumes we want an instance field. Let's discuss a little more about classes before getting into the definitions of static and instance fields. When you learned about strings earlier on, they were defined as objects due to the ability to call and use certain methods. In other words, there were built-in behaviors that strings could perform. What you may not have realized at the time is that in order for strings to be objects in the first place, they must be a class within themselves, a class which contains all the methods that you're able to use with them. What does this mean? Any object, not a primitive data type, declared in your programs so far has been done with a built-in class. For example, int_array sum equals new int_array of size 5. Arrays are objects and therefore have a class devoted to storing their behaviors and methods, thus you can define variables with them. The classes you will be creating will have the ability to create unique objects with behaviors you define. To further explain, let's go back to our restaurant program which contained the class server. While we wrote the program simply to introduce you to classes, the object classes you created have much more use. When you created the class server, what you created is the ability to have as many server objects as you would like or need. These are called instances of a class. Every time you declare and initialize a new variable of type server, you create an instance of the server class with its own attributes and behaviors. Every object is created using the keyword new, followed by a call to one of the class's constructors. Since a restaurant would have many servers, it's easy to see the need for several instances of the server class declared below. So here we have the server class, which is basically the blueprint for how to make a new server, and then the object, which is an instance of that class. And the objects here are servers. So Emily, Jake, Katie, and Bobby are all instances of the server class, or you could also call them objects created from the server class. So what does this have to do with static and instance fields? Static fields belong to the class. Regardless of the number of instances and objects created, a static field holds the same value for all. Instance fields belong to the instance of the class. They are unique to each object created and can hold different values depending on which instance is being referred. For example, let's declare two fields in our server class to store the number of tables servers will have at any one time. You will see how each has a different effect on our overall program. So static int numTables versus int numTables. Remember to declare these outside of any methods in the class. Also, they will not be private because we will want the restaurant class to access them. We will work with the static version first. So here we have our server class, and down here we have our getDrinkOrder method and our getFoodOrder method. That's all down here. But right here, outside of this method, above it, we have static int numTables. So go ahead and compile the server class and then open the restaurant class. Declare a few variables of type server in your restaurant class like this. So in our restaurant class, in the main method, we are going to use the server class to create 3 new objects, 3 new instances of this class. Those instances are called Emily, Jake, and Katie. Assign different values to various server variables, compile, and see what happens when it runs and prints. All right, so here in our restaurant class, we have our 3 new objects, Emily, Jake, and Katie, which are all servers created from the server blueprint, the class here. Then we're going to say katie.numTables equals 5, jake.numTables equals 3. Then we're going to print the values for those. While no compiler errors occur, numTables only stores the last value assigned to it in all instances of the class for all server variables. This is because in the server class, it is a static field currently and can only hold one value. Notice how, regardless of what you assign to Katie as the number of tables, the program outputs the same value that Jake does. That's why it printed 3 twice. So no matter how many servers you have in the restaurant, they will all have the same number of tables. If we actually wanted every server to have the same number of tables using a static field, we would assign a value to the overall class like this, versus using an individual instance. So instead of saying katie.numTables equals 5, we would use server.numTables equals 5. But that's not our goal. We want each server to have its own number of tables. Since we do want each of our servers to have a different number of tables, let's implement that. Go back to the server Java file and remove static from the field declaration so that it now looks like this. Remember, there is no instance keyword. It is implied by the absence of static. Compile it and return to the restaurant Java file. Now that numTables is an instance field, it can hold several values. Retype the prior attempt to store different values for Katie and Jake. What happens this time when you compile and run? Well, this time it's going to print 5 and then 3. Each server variable stores its own value for numTables.